So we're going to talk about my favorite subject, other than Jesus, obviously, but math and Jesus, what a great combination. I am a scientist and an engineer, so obviously I like math. I've taken pretty advanced math. I know most of you are probably groaning. But if you noticed in the handout, there's a lot of pretty pictures. I think you will see that. The main idea we want to talk about today is, does the concepts and functions and complexities of math point us to a creator? Yeah, I think it does. I mean, the premise that we'll talk about is the fact that math is conceptual, it's metaphysical, and yet it mimics what we see in the physical world. Naturalists usually deny that there is a metaphysical world, but all their concepts come out of the mind, which is metaphysical. So they actually tend to counter their own arguments and cancel them out on their own. So we'll kind of let them do that. We're going to try to look at both pluses and minuses. I want to see what the atheist has to say so we can try to counter their claims. And we're going to be walking through both the why and the why nots that people say about the evidence for God. Obviously, as Christians, we believe these are evidences for God, but people challenge our views, and we should always be open to those challenges. Part of the advantages of looking at the critiques or the challenges of our faith is when we can talk about and discuss and understand the counter to those critiques, our faith gets stronger. You always get stronger in your view if you can handle the critiques. I mean, I always say I won't get ahead of myself, but we're going to be talking basically assuming people are struggling with God. You know, we got to always know where they are in our continuum when we have one of these conversations. And we're going to be talking about some of the 101 plus evidences for God that I've talked about. We'll be focusing on math. I won't do Aquinas' 5 reasons today, just don't have time. I actually don't know how long this is. I didn't ever practice it, so we'll see how we go. But we're always going to be looking at the counter so that we know how to address their concerns, their misconceptions, and their doubts. And their arguments against the evidence that we see clearly points to God is always going to fall into these categories. And that's one of the things I want to try to point out as we go through the class is the atheist perspective is consistent in the fact that they always fall back to the same set of arguments against what we present to them. Yep. It's a small number, and it basically is when they don't know, they just say there's nothing to see there. You know, it says don't worry about it. That's your brute facts or your necessity arguments. Or they'll say they're doing science when they're really doing philosophy. And that's what we want to watch out for when we see their counters to the evidence that we're going to be talking about. How are they framing it? And then that exposes the weakness in their arguments, okay? It's all right. But we're going to look at pros and cons, right? Because I think that's the only way to be intellectually honest is to look at both sides of the arguments. So math, fractals, logic, reason, that's the topic, as boring as you guys may think it is, but I hope I can change your mind. I love this stuff because, well, it's what I've been doing for 40 years. But we need rules of engagement. Anytime we get into a discussion, and you should do this if you have an atheist friend or colleague or someone, and then you get into a discussion, you don't have to set it up like this, but you have to actually establish a framework for that conversation, or it just becomes my argument, your argument, back and forth, you will accomplish nothing. So for our purposes, we're going to talk about the critiques of viewpoints. You know, I believe, and this is a premise I use in my own personal studies, is I want to look for the strongest critique about or against the thing that I believe in. Because I know if I can address that critique, my view got stronger. Most people run away from the critiques. They don't want to see what disagrees with their view. And sometimes you're going to find out you're wrong. And guess what? That means you can change your view and then you can be right again. So it's always a good thing. And we're going to apply what I call equal burden of proof. Generally in a discussion, whoever makes the claim is responsible for providing evidence for that claim. But in this forum, I think we should be equal on our footing. So we're going to make claims, and we're going to see how the atheist counterclaim looks. And the level of scrutiny for both of those should be equal. So if they're going to dismiss a certain path of logic, they can't turn around and try to use it to support a different view. And that's what we're really trying to look at, is there is logic and reason that should be used consistently, regardless of what your argument is. And we'll see one tonight that they use constantly to establish the so-called proofs of evolution. Yet when I use it to prove God, they're going to say, no, you shouldn't use that argument. It's the same logic and reason. So I'll point that out when we get there, because it's exactly what the evolutionists, the origins of life, the old universe models all use this same logic and reason, because you can't see any of those things. It's a philosophy. You have to make assumptions. Okay. And so I think I'm not going to do this in each of the sessions going forward, but I think it's good for us to always understand that as Christians, we have bias. You might think you're not biased. That just means you're biased, okay? Biasness is the things you come to the table with. It's your starting point in a discussion. And as Christians, when it comes down to math and reason and logic, we believe it can be understood by our mind because it comes from the mind of our Creator. Our universe can be understood because God made it that way, right? And we're made in the image of God so that we can process things the same way that God has designed things. So we also believe in both the physical and the metaphysical. Metaphysical are things that are just in your mind. They're concepts. They're things you can't touch or feel or even observe. As Christians, we believe in both. Now, as a naturalist, they have a different set of bias. They believe math, reason, and logic are necessities. There's no deeper meaning. They have to be this way because of the universe we live in has it. So it's just the way it is. It's brute facts argument is what it is. That's their bias, that there's just nothing more to look at. We disagree with that, and we'll talk about why that is. And then one of the weaknesses of the naturalist view is they only believe there's a physical realm. They don't believe in the metaphysical. It's only physical. It's only natural. The problem is all the concepts they use are philosophy, which is metaphysical. The concept of evolution is a thought. We can't observe it. We can't see it. We can't prove it. It's metaphysical, okay? And I'll prove that numbers and science are really metaphysically based. We're using a concept of our mind to process the physical world. Metaphysical and physical are almost always overlaid, because your mind is not just chemistry, no matter what they tell you. So we're start with logic. I know everybody's going to love this. This one's a little tough. I'm just going to use one example for the way logic kind of points toward God, okay? This is called the contingent chain. I know you don't know the term, but everybody uses it. Effectively, it means A causes something that makes B, causes something that makes C. It's like following a recipe to make a cake. That's a contingent chain. As a Christian, we believe there's what they call the necessary ground. That's the starting place. That's the first cause. There has to be a point that's outside of the chain that initiates this chain in its movement, right? So an infinite chain of borrowed existences, which is what our existence is, right, never becomes self-existent merely because you add length to the chain. That's the Christian concept that billions of years doesn't really help them. They always have to have that necessary ground, that first cause in all the different scientific models that they'll say for the existence of the universe or the origins of life. Or go ahead.
Can you read that in layman's?
Okay, let me go forward a little bit. I know the logic is tough, okay? So the Christian view would be that it identifies God, right? God's a necessary cause. A contingent chain is just like, think of it like following a recipe, right? Point A is required before I get to point B. Point B is required before point C. So there's a chain. We see this over and over in our existence. But there's always something outside of that chain that started the chain in motion. That's what we call the necessary ground. And that's where the naturalist and the Christian deviate, well, as long as we don't call the necessary ground God, they'll agree with us. Because everybody knows this is the way it works.
But what is their necessary ground? What do they say?
Like the Big Bang.
There's nothing to see here.
Bang theory.
Yeah, they'll say Big Bang for the universe, origin of life.
But his point is that like they don't really have an explanation for
Right, I
the
understand.
Big
What,
Bang,
I understand. I'm just saying, what are they saying is their necessary?
Yeah, so if it's evolution, they'll say we come from monkeys, right, or bacteria. You talk about origins of life, you say, well, there's some chemistry that was in a pool someplace on Earth and lightning struck it and then boom, now we have life. The problem is, as you roll back, you really look at their contingent chain. It always gets to a point where there's a gap. Something outside of that chain has to take place in order for that chain to even get started. And we don't agree the chain even exists in the case of evolution, but that's for a different day. We'll talk about that. But
So am I necessary ground when I start to make the cake?
yeah, you're initiating. You gathered the ingredients,
So I would be the necessary ground.
but those ingredients could be used for lots of different things, right? Right. So yeah, you're the necessary ground in that example, which is a little simplistic, but it's the idea that it's got to be something outside of the chain that initiates the chain. Yeah, and it's one of these things that's it's kind of obvious to us functionally in the world. I mean, there has to be a starting point to a sequence of events that take place. But if you always run it back, it ends up with absurdity. There has to be something beyond what naturalism says. And that's the reason this is an evidence for God according to Christians. We believe that necessary ground has to be God, right? The ultimate necessary ground. But the atheists are going to counter us. They're going to come with a couple of different paths of arguments. There's different views. One's going to be the anthropic one. Anthropic just means it's human-centered. They will say, well, it appears this way because this is the only universe we can actually observe, and it's the way it is. And nowadays, they'll always morph it into the multiverse weird concept that there's infinite different possibilities that will have different outcomes. And we just are observing the one that we're observing, so therefore, it's just the way it is. And that is a whole lot of hand-waving with no thought. There's no reason to that. That's imagination, okay? Their concept is, yeah, we know that there has to be an initiating cause, a necessary ground. We don't know, but it can't be God. That's really their view. And if you don't like that one, they'll go, okay, what? Yeah. They'll talk about, and I know this is even more logic, they talk about no agreed priors. That means they'll just truncate the chain and say, well, nothing happened before that. What are you guys talking about? We can't see it, we can't observe it, so there's nothing. It just is. And that'll be one of the arguments you hear from very smart scientists. When pushed into a corner, you'll get, well, that's just the way it is. Why is it so illogical to you? Because you're using logic, you're using philosophy.
That's how we see God.
That's exactly how we see God. So part of our job, especially with the modern scientists, is show them that we're on equal ground. Now let's look at what's the best explanation for what we see. Okay, we're on equal ground. I would say the logic and reason really puts us on equal ground. I think it leans toward the existence of a supernatural ultimate cause. That just makes more logic and reason to me. But you have to build this case with more than one piece of evidence. So this is also a little bit of a logic argument. Wigner was, in 1961, he's a physicist, and he got really famous because he put into words what I think everybody else already knew, that the enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious. In fact, I've heard it quoted differently, that he calls it miraculous. I mean, why is this? Well, that's a really good argument for God, actually, if you think about it. Why is it that math fits our natural world so well? How can we model things? That's a metaphysical, and you're able to see and model and predict things in the physical. So as a Christian, we're talking about the intelligibility of the universe. Intelligible just means you can figure it out, right? You can think about it. And we have very complicated math that we have developed in science and mathematics that can model things that happen in the universe, in our world, that we can observe. And so there's an inference here that I think Wigner was getting to. He never got to it in his lifetime, but that there has to be some sort of inferred rational source of mathematics in order for them to model the real world so well. And I think our argument usually goes like this. It's something like, so a theist would say that math seems to explain not only just the world that we live in, but the question is, why can we actually decipher the world with mathematics? It's one thing to describe it with mathematics, but you can actually decipher things with mathematics. Through mathematics and science, we have discovered things that if it wasn't for the math, we wouldn't even know to look for it. So there's this weird combination, again, the metaphysical and the physical, conceptual and the real, overlapping, and the question is why? And the naturalist doesn't have an answer for this, but the first thing the atheist is going to do is going to say, why are you surprised? I mean, seriously, I've seen this in debates. It's like, why are you surprised? Math was designed to do exactly this. Exactly. Exactly. But most of these counter arguments are meant to be distractions. They're meant to catch you off guard and get to a different topic because they can't win this topic. Okay, they can't win it. And another one, and this is one that is, it's called the incoherent argument because they'll prop themselves up in their PhDs and whatever else they got, and they'll say, well, I'm just smarter than you. Your argument makes no sense. Makes no sense. It's incoherent. Your definition of who God is doesn't match what you're talking about. These things don't match. Your argument is completely incoherent, so I can dismiss it, even though I can't argue against it. And this is a very classic atheist argument against the things that we consider to be truths and evidence of God. Because I can't argue against it, I'll just say that you guys are just crazy to think about that. It's like, what about it is crazy? It's just crazy. And that's where you deviate from logic and reason. So I know that is kind of quick through logic and reason, but they're not using logic and reason, is I think the moral to the story. If anything, we're on equal ground. I think it leans toward theism. Well, that brings me to math. What are numbers? Does anybody know? I'm sure you know. Wait, don't say it yet. I did tell you last week. What did I say last week? They're concepts, right? Concepts of quantity. That's probably the best definition for a number. But is that a number?
Yeah.
One? Eveline, can you say that number for me in Spanish? Judy, can you say it in Bicol? How about Tagalog? So which one of those is one? Well, but it's not the same word. Why is it consistent? It's a concept. It's a concept, and language is describing that concept. So 1, 2, 5. If we said it in different languages, it's going to sound different. Is this symbol magical? What about these? They can be the same, they're just different representations. The symbol is not the number. If I deleted number 2, 2 does not disappear from the universe. It's just a representation. It's a concept. So when we talk about numbers, you got to recognize it's like these blocks, right? 2 plus 2 is equal to what? 4. If this was zip, zip, and zip, zip, it would still be the same quantity, no matter what you call it. It's a concept of quantity. numbers in themselves are actually nothing. And I know most of you think numbers are nothing already, but that's but numbers are just a concept.
Talk like that around Dan.
But there's different kinds of numbers, right? You got negative numbers like minus 12. You got big numbers like 12,500. And then you have numbers like three-eyed. Who knows what the I stands for? It's imaginary numbers. They're not really imaginary, okay? It's a concept. An imaginary number, when you square an imaginary number, it's a negative number. Now, if you know basic algebra, that doesn't seem like it makes sense. Those are real numbers. They just have there's a different concept that it's representing. So imaginary numbers are real. When you square imaginary number, it's a negative number. I know it messes your mind, but it's real concept. Again, it's a concept of quantity that is describing something in the physical world, and this is just a mathematical representation of it. That's all math is. Numbers is. Numbers are just a concept of quantity that's being used so we can tell the difference between 2 plus 2 is equal to something other than 4. So it brings me to math. What is math? Math is the application of that concept, right? I mean, 2 minus 1 is 1. 2 times 2 is 4. A plus B equals C. They can start getting algebra. You can get into more complicated things like equals MC squared. The one at the bottom, that's quantum mechanics. That's a Laplace transform. I can't do that anymore. I used to do it when I was doing that sort of thing. Math can be quite complicated, but again, it is still an application of the concept of quantity to explain the observable world and maybe predict something that would happen in the observable world. Do you understand? You understand how it's a concept of the mind used to explain what we observe or to allow us to communicate about what we observe.
It can be independently discovered in multiple places because nobody develops math. It's just coming to an understanding of how these things work.
It's an excellent thing. I should have said that. Math is discovered. It's not developed. Some people...
Pythagoras' theorem, right? That was independently discovered by the Chinese, by Pythagoras in Greece, and then also by the Egyptians.
Yep.
So there was 3 different theories, but it all explains the exact same thing.
Yeah, and Pythagoras gets the credit, and his was the last one to develop it. You'll figure it. But again, math is just a concept, the application of a concept to explain what we see. So now that's my foundation. Math is less scary than you think it is. It's just a concept of your mind.
What's language?
Exactly. We'll talk about language next week when we talk about what information is. Math is part of that information chain. But I want to just zoom into 2 plus 2 equals 4. Why is 2 plus 2 always equal to 4? Can it ever be 2 plus 2 equal to 5? Are you sure? There are people that will tell you that it can be. And I always want to say, it's like, okay, I'm going to give you $2. My wife's going to give you $2. You give me 5 back. And we can do that all day until you accept the fact that there's a truth in numbers. Okay? I mean, there just is. And that truth has to come from a source. That's the thing that is important in this. There has to be a standard in order for us to have a truth. And the question that we're going to have to ask is, what is that standard? As Christians, we believe it's God. As a naturalist, why is this? And that's a big question for them. So this is kind of where they come to. In the Christian world, we'll talk about the contingent chain that we talked about. We'll talk about how patterns come from a mind. That's the reason there's patterns. We'll talk about the complexity of the universe as evidence for God. And the fact that the physical and the conceptual merge and are consistent is evidence for God. The atheist is going to go down the obvious path. It's going to choose brute facts or necessity and say it's just the way it is. Because this is the only universe that we got. This is the only one we can observe. It's just the way it is. There's nothing to see here. Then they'll go after our God. And they'll say, well, if you're right, It's almost a conceding that our explanation's better than theirs. They'll talk about divine hiddenness and the fact that your God doesn't make himself obvious, so why would you think that God is the origin of numbers? And I'm like, I don't think whether the God chooses to make himself known to you is important on whether he's the origin of this information. This is like a bait and switch, a distraction technique. They'll always go to God of the gaps. They'll say, okay, you say God's the best explanation. Okay, I get it, but someday science will have a better explanation. Today, which one has a better explanation? Because, remember we talked about it on Sunday. God says we need to be focused on him on every day that's called what? Today. 10,000 years from now, they don't know either. They're just imagining it because they don't want the obvious. And then the last resort is always the incoherence. And it's almost a sequence you'll see from the atheist. When they're trapped, they'll just say, well, the way you define God is incoherent with the argument you're giving me right now, so this cannot be the possibility. It's very consistent. So it comes down to this. As a Christian, we say God is the ultimate cause, and we use a cumulative case like we've talked about. We look at the evidence and let the evidence lead us to the truth. An atheist says anything but God. That's their premise at their start. That's their bias. Can you be reasonable if you start with anything but? So the reason's out the window. If they were reasonable, they'd have to leave it in and then prove it's not true. And then they want to use parsimony. We talked about parsimony a few weeks ago. Parsimony just is the simplest answer. That's the best way to say it. I believe parsimony actually proves the Christian worldview because I think God is a lot simpler answer than thousands of unknown things. That is the atheist worldview. That their simpler solution is the laws of nature, which they don't know yet. That seems more complicated to me. All right, so now you're going to listen to a video, and this is a guy from Answers to Genesis. It's about 15 minutes talking about the Mandelbrot set. Some of you know this video. You're going to enjoy this.
I dare say there is no secular or atheistic explanation for what I'm going to share with you. This secret code only makes sense in the Christian worldview. What if there were a code embedded in numbers like 1, 2, 3, 4? What if there was a secret code embedded in them that we finally got around to discovering? What would that imply? What if there was a message inside numbers? What would that imply? It would tell us something about the intelligence of the person who made numbers. Now, we don't often think about God creating numbers because they're abstract. We think about God creating animals and stars and planets and so on. But numbers, God is responsible for them as well. Even though they're abstract and conceptual, God's sovereign over the abstract just as much as he is the physical universe. And as a matter of fact, there is a secret code built into numbers, and it is mind-blowing. And this is something that I read about when I was pretty young, really, and it was mind-blowing to me. And I want to share this with, it's called the Mandelbrot set. This was discovered in the late 1970s, early 1980s, named after the person who really discovered this, Benoit Mandelbrot. He was a math guy and a computer guy. He worked at IBM. This set is defined according to this little formula that you see right here, where it's the set of all numbers. C is a number that is potentially part of the Mandelbrot set. We're testing it, for which this other number, Z, remains small according to this little formula. And it looks very complicated, but it's really not. I'll take you through it. What we can do then is we can make a map, because I'm trying to figure out if there's a pattern to the numbers that belong to the Mandelbrot set. And it turns out there is. But it's not obvious, right? Because you can't tell just by looking at a number whether it's going to belong or not. You have to run it through that formula, and that's kind of tedious. But in the 1980s, computers were starting to get fast enough where they could iterate that formula a number of times, and they could analyze to see whether Z is getting big or staying small. And so what we can do is we can have the computer check all these different points, and we'll see if there's a pattern to the Mandelbrot set. And so we'll take the points that belong to the Mandelbrot set, and we'll color those black. That's arbitrary. That's the way Benoit Mandelbrot did it, and we follow his example. So, and you have the computer check more points, and you find that all those points right there belong to the Mandelbrot set. When you run it through that formula, z stays small. And then the points that do not belong, we'll color those red, or some other color. It doesn't really matter. And so we already checked the point 1. We found that the number 1 does not belong to the Mandelbrot set, so it gets colored red. And had we checked these other points, we would find that they do not belong. And so you see, as you plot more and more of these points, a pattern starts to emerge. What's it going to look like? Well, you have the computer run through thousands and thousands of points. You have the computer check each one of those numbers, and a pattern emerges, and the pattern looks like this. It's really interesting and unexpected. Nobody was expecting that when you made a map of the Mandelbrot set, it would look like that. Remarkable. I'm going to remove the axes now, because it turns out the shape is remarkably interesting and unexpected, and it'll turn out to have a lot of beauty in it as well. The shape itself is, this is a mathematical plot. I guess we'd expect it would have some mathematical properties to it, but everyone was surprised by the properties it has. The main shape that looks kind of like a heart, that's called a cardioid. And a cardioid is what happens when you take a circle and you take your pencil on it and roll it around another circle of equal size. The shape you'll get is a cardioid. And you can see that, sure enough, the main part of the Mandelbrot set is a perfect cardioid. All the other shapes that are growing off of it are circles. All these perfect circles attached to the perimeter of the Mandelbrot set. And then you see some other features, like these little tendrils that grow off of it, and a spike over on the left, kind of that juts out. That's kind of interesting. You notice that that top circle there, it's got a circle on top of it, another one on top of it on smaller and smaller scales, and it goes out and forms this little tree, and it's got 3 stems to it, including the trunk. So it's got a trunk and 2 stems for a total of 3 branches. You see that there? Now the next one to the left branches into 5. Can you see that? It's kind of small, but you can see the 5 branches there. The next one is 7, 9, 11, 13, 15. It's all the odd numbers. And by the way, they don't stop. They go to infinity. There's an infinite number of them. They get smaller and smaller, though, and so you have to zoom in more. So somehow the Mandelbrot set knows how to count. It's kind of remarkable. And then on the other side, you have the odds and the evens. You have all the numbers there in terms of the number of branches. Now, it's remarkable enough that they have branches at all, because who would have thought that when you run numbers through that little formula, you get that shape? It's remarkable. Nobody was expecting that. And it's even more remarkable that it has the ability, apparently, to count in terms of the number of tendrils that grow off of each bud there. And, of course, you can take 2 of those numbers, like 5 and 3. Now, 5 plus 3 is 8, okay? And it turns out that the bud in between those 2 has 8 tendrils. Interesting. And that's true of all of them, both on the left side and the right. The bud in between the 2 adds the number of tendrils on each one. So not only does the Mandelbrot set know how to count, it knows how to add. And then on the left side over there, you got this kind of spike that goes out. And you see there's this little bump on the end of the spike. So let's take a look and see what that looks like. So we'll zoom in on it. And that little bump, turns out, it looks like the entire Mandelbrot set. It's a mini Mandelbrot set. And it's almost identical to the parent, except it's got extra spikes growing off of it. But the basic shape's the same. It's got the cardioid and the circles. And, it has a little spike growing off of it, too, with a little bump. What could that be? Well, let's zoom in on that. And, interesting. Absolutely fat. And it's got extra spikes growing off of it. And that's got a little bud. How about that? Now, of course, you could do that literally forever. And there's an infinite number of baby versions built into the Mandelbrot set on smaller and smaller scales. And take a look at how small this is compared to the original when we zoom back out here. Look at how tiny it is. Isn't that remarkable? And the fact that it repeats infinitely, and it doesn't lose complexity, it actually gains it each time you get more extra spikes growing off of it. Very remarkable. Well, to anticipate my conclusion in this, I'm going to suggest to you that this shape tells us something about the way God thinks. God's understanding is infinite. Numbers are an aspect of God's mind. God is responsible for numbers. And so it makes sense in the Christian worldview that when we explore and study numbers, we find intelligence in them. We find evidence of patterns. And not only intelligence, but infinite intelligence, because this thing repeats infinitely. A structure that repeats itself on smaller and smaller scales is called a fractal. So the Mandelbrot set is one example of a fractal. There are other types of fractals. There are other sections of the Mandelbrot set that are fractal. We could zoom in, for example, on one of these little tendril features here and zoom in on that. And you'd say, well, that's interesting. You think what's going to stop at some point, right? Eventually it'll even out and you'll get, but it just keeps going. It's infinitely wiggly, you see. It's wiggling around like that, and you zoom in on it, and it keeps going and keeps going and keeps going. It's just mesmerizing to watch this thing and see the scale here. And it gives you a little taste of what God's mind is like, to be able to think infinitely. We can only process just a little bit of information at a time, but God's mind is truly infinite. So one of the interesting areas to explore, and what I want to do now is just kind of spend some time exploring this shape that exists in the mind of God and has existed in the mind of God from creation, that was only discovered in the 1980s. And we can zoom in, for example, on this cusp between the main cardioid and the disc. And we find they call it the Valley of the Seahorses, because you see over on the right side, it looks like seahorses. They're upside down, because the way I've zoomed in on them here. Now, the colors are arbitrary. I can make them whatever I want, and we'll change them every now and then just to keep things interesting. But just keep in mind, black always represents numbers that do belong to the Mandelbrot set, and then colors represent those that do not belong to the Mandelbrot set. And bright colors are very close to being on the Mandelbrot set, but not quite a part of it. So let's zoom in on one of these seahorse structures over here. You see it looks like an upside-down seahorse. Isn't that fascinating? And quite beautiful. And I need to explain a little bit about what this means, because if the points are very bright, that means it's very close to the Mandelbrot set. And you might look and say, but yeah, that bright hub doesn't look like it's anywhere close to it. It is. It's just, you need to realize that there is a very thin black thread that's wiggling around and making that shape, you see. It's just so thin, it's thinner than the pixels that the computer can plot. So everywhere you see structure like that, there is a very thin black thread that's winding around and creating that wonderful shape. Well, let's zoom in and find out what this seahorse is made of. It's the central hub there looks kind of like a spiderweb type structure, right? You got the spokes and the rims around there. And I found from experience, you can zoom in on the center of that till your heart's content, and it doesn't really change very much. It goes on infinitely. So again, the infiniteness of the mind of God. And so I thought, well, okay, let's go off to the side and figure out what the strands of the spiderweb are made of. So let's go off to the side here, and we find that the strands are made of more spiderwebs, which is kind of interesting. And we zoom in a little bit more, and you find that there's sort of two hubs there. You see the bright yellow hubs. And then in the middle, it goes from 2 to 4. And as we zoom in, it'll go from 4 to 8 to 16, 32, 64. It doubles each time. And as we zoom in on that central hub, we find, oh, isn't that interesting? You see it going from 4 to 8 to 16 and so on, and in the middle, of course, you have another baby Mandelbrot set. Quite fascinating, really. And again, there's an infinite number of these babies built into the overall shape, which I think is amazing. And again, look at how small this is compared to the overall shape as we zoom back out. It's just a tiny little infinitesimal, and we could have zoomed in on any one of those strands. I just picked one at random, and there it is. So pretty remarkable. Let's go back to that valley. Now, the Valley of Seahorses is on the right. On the left, we find the Valley of the Double Spirals. And I'll zoom in on one of those now. This is my favorite part of the Mandelbrot set. I think they're very beautiful. They remind me of spiral galaxies, actually, which is an astronomer I really appreciate. God apparently likes spirals because he's built a lot of them into nature, and he's built them into math, which is remarkable. Who would have guessed that there would be a spiral, a beautiful spiral, built into that little formula, z squared plus c, or rather built into numbers when we run them through that formula. Pretty amazing. It's a double spiral because there's actually two strands that wrap around each other. If you trace one strand, you'll find that there's a strand in between. And so it is a double spiral, as are spiral galaxies, by the way. And let's zoom in on that a little bit. And again, I've found you can zoom in on the center forever, so we'll zoom in on the side, and you find the spiderweb type structures, you find more double spirals, and you find a new structure. I call them bow ties. They're kind of in the middle. You see it looks like kind of like a little bow tie, right? And it's got two double spirals that intersect in the middle. Quite beautiful. Again, what you're seeing here The Mandelbrot set, it's just incredibly wiggly. It's so wiggly. It's making these wonderful shapes. And that's what the points that are very bright are very close to that thin black thread that's wiggling around and making all these wonderful shapes. So we'll zoom in on one of these bow ties. And we find that it's, again, you have the two double spirals. We zoomed in on a double spiral, and we found that it's made up of multiple double spirals. And they go from 2 to 4 to 8 to 16 as we zoom in on the center there. And in the middle, you find another mini Mandelbrot set. You're not surprised this time, but there it is. And quite beautiful. Who would have imagined that such beauty would be built into numbers? Well, in the Christian worldview, that makes sense. We serve a God who is beautiful, who makes beautiful things. And when we examine the way God thinks about numbers, which is what mathematics really is, we find it's immensely beautiful. All that, just a map of what numbers belong to that little formula when you run them through that algorithm. Isn't that fascinating? And this, of course, was astonishing to mathematicians when this was discovered back in the 80s. So then it occurred to me, well, is there something special about that formula? I mean, did we just happen to stumble upon to an amazing formula? What happens if we change it? So I thought, okay, let's take, what happens if we go z cubed plus c? Well, I ran the computer code through that, and it turns out you get a different shape. Interesting. And very similar in some respects, but different in others. The shape here, the main shape, is called a nephroid. A nephroid is what happens when you take a circle half the size of another and you roll it around. Then you get that shape. And you can see it's a perfect nephroid. Really amazing. And then instead of circles growing off of it, you have cardioids growing off of it. Notice everything's gone up by 1. The Mandelbrot set had a cardioid which has 1 valley. This one has a nephroid which has 2. And the circles growing on it, which have no valleys, now are cardioids which have 1 valley. Everything's gone up by 1. That kind of makes sense. We went from z squared to z cubed. I guess that makes sense. Okay, what happens when we go z to the 4th? Well, that's what you get. Okay, what happens if you go z to the 5th? Interesting. You notice the number of lobes is 1 less than the number. So z to the 5th, you get 4 lobes. Z to the 6th, you get 5 lobes. It occurred to me if I went z to the 7th, I could get snowflakes. And you sure do. And if you zoom in on it, do you get snowflakes? Absolutely. You zoom in on it, you get snowflakes everywhere. Isn't that wonderful? Did you know that such beauty was built into numbers? Okay, so what does all this mean? We got these wonderful shapes, and it's very pretty, Dr. Lau, but who cares? Well, I want to ask, what causes the beauty in fractals?
So I think that's a great question. You can look online and find the Mandelbrot slit. There's a lot of generators out there. If you want to see the whole video, it's an hour long. Look up Answers with Genesis Mandelbrot set, and it'll take you to Dr. Lyle's video. There's several of them out there. Like I said, there's a lot more to it. I just had to truncate it. But he asked a good question. What causes the beauty in numbers? I mean, we're just graphing numbers, but it's beautiful. I mean, everyone can see the beauty, and it's not just colors. If you go on with his talk, he changes the colors to just black and white. It's still beautiful. It's not the colors. The colors are his artistic flair. I like what he did. Why? Well, Christian worldview, it's quite easy. Like he said, we serve a beautiful God, and he created beauty for us to enjoy. Atheist worldview is going to say, pattern does not imply person. There's all kinds of patterns in nature. There's crystalline forms that don't generate beauty, although I find them beautiful. I love crystals. But that's going to be their argument. They're going to say, fractals, crystal growth, branching trees, turbulence, all these different things. There's rich information, but they're generated by impersonal rules, like a mathematical formula. So why do you Christians think it implies God?
Somebody had to think that.
Somebody had to think about it. And why does it generate? This was not predicted to generate such beauty.
Not until 1980.
Not until 1980. We had to have a computer to run it. You can manually plot the Mandelbrot set. He talks about this in his video. But it would take, you need hundreds of thousands of iterations just to get the original shape, and then all those little detailed ones. Yeah, so as we get better computers, actually my friend Walter plotted this for me, so I have a little engine that I can play with. Like I said, you can find them online. I mean, it's not sophisticated math, believe it or not. It's just it takes a pretty significant computer to plot it.
Is it God because it's absolutely perfect?
Well, I think it's a good indication. I think the reoccurring fact and the infinite fact, or the fact it does math, is a remarkable trait. But the question I asked, and is it just the Mandelbrot set? You know, is this the only one? He showed you variations of it, but it was still basically the same formula. So I'm going to show you about 2 more minutes of his video. He's going to talk about fractals.
From above, and they kind of branch, and they branch into branches. And so on, clouds tend to be fractal. They don't repeat exactly, but am I looking at the entire sky, or am I looking at one very small section of the cloud? It's hard to tell, because the same kinds of patterns repeat. The way lightning branches is fractal, because you have a main bolt that branches into smaller bolts, which branch into smaller ones, and so on. And so lightning, very beautiful, and because it has that fractal quality to it. And it's really neat, too, when you watch it in super slow motion. You can see how it branches out into all these different branches. That's a fractal, until the leader connects, and then most of the current goes down the leader. Quite fascinating. So here's my question, then. Why do fractals occur both in math, which exists in the mind, it's conceptual, and in the physical world, which is made up of atoms and does not exist in your mind? Right? I mean, you have this shape, that's a multibrot, that exists only in the conceptual world of mathematics. We can plot it, but you could never touch that thing because it's not physical, it's not made up of atoms. But that one is, and they look remarkably similar. This particular shape here is part of the Mandelbrot set, looks like a bolt of lightning, but it's not made of atoms. This one is. How is it that conceptual things that exist only in the mind also occur in the physical universe? This particular shape, that might look like a plant that's actually a mathematical graph called a Barnsley fern. And a Barnsley fern is such that each leaflet is the entire shape. Let me show you. Isn't that interesting? Let's do it again just because it's cool. See, the entire shape, each leaflet is the entire shape. Fascinating. You can't touch that, though. It doesn't exist in the physical world, but that does. It's very similar. This stuff right here, that's a mathematical graph. That doesn't exist in the physical world, but that grows on your windows. This particular mathematical shape, cones on cones, it does not exist in the physical world, whereas this, unfortunately, does. This particular shape, that's part of the Mandelbrot set. It's a double spiral. You can't see that in a telescope because it's not made of atoms. It doesn't exist physically in the universe, but that one you can see it in a small telescope. The Whirlpool Galaxy, not too far off from the Big Dipper. So how is it that math, which is conceptual, you find these shapes, and then in nature, which is physical, you find the same kinds of shapes?
So it's a great question. In case you didn't get the joke, this is a kind of broccoli, you know, so it's like, unfortunately it exists. Most people don't like broccoli. Pine cones are the same. But as you look through this, I mean, which is real and which is conceptual? And which is not beautiful? I mean, both the conceptual and the physical are beautiful. Why are both the mathematical conceptual world and the physical world the same? Well, as a Christian, we believe it's because there's a creator. But I want to take it a step further. I may run a little late, but I think this is cool. I'm going to just talk about 2 other mathematical formulas. Helix and vortex. These are common if you do trigonometry. It's not complicated math. It just looks complicated. And there's lots of different forms of it. When you graph them, they kind of look like this. And even though they're colored, if I didn't color them, they're actually still kind of cool. They're pretty. It's very interesting. Now I'm going to show you versions of these, both mathematically, conceptually, and then in the physical world. This is what they call a torus or a vortex ring. This is Mount Etna in Italy generating vortex rings, smoke rings. Those are smoke rings coming off of Mount Etna last year. I got this from Wall Street Journal. It's the tag's there. So you see the physical world generating things amazingly beautiful that are also seen in the conceptual world of mathematics. So I thought that was cool. Now this one, we might have some familiarity with. This particular storm I have a lot of familiarity with. This was Pepito or Magny. At the time you see that eye wall, it was probably the strongest typhoon on record. And my family and I are right here of November 2 years ago. It was a lot of fun. It died down as it came on. I think it's the top 10 now as far as the landfall. But again, look at the physical world and the conceptual.
And they always turn the same way.
Depends on which side of the equator you're on.
Right.
They turn the opposite way on the opposite side. Now well, what about this one? I mean, obviously, he talked about whirlpool galaxies. We live in one. It's called the Milky Way. It's beautiful when we see this in a telescope. We see it on TV. Mathematics, conceptual mathematics, generate the same shape. Now, why is the conceptual and the physical so consistent? Another one, you see this one every time you drain the tub or a sink. It's an inward spiral vortex. The mathematical formula for it's right here on the right. Even if you didn't see the one on the left, it's still beautiful. How about this one? This is from Wallace, Nebraska last June. Wallace is maybe an hour from where I grew up. Mathematics are conceptual. Tornadoes are very, very real. But again, can you see how the conceptual and the physical, and why is that? That mathematical formula was not designed to mimic the tornado. We use that mathematical formula to predict tornadoes today, but the math came for different reasons. It's just simple vortex. Yeah, the storm chasers are crazy, right?
Yeah.
Plus, they're from Nebraska. They probably are really crazy. People from Nebraska are crazy. I should know. I am one. But again, see how the physical world and the conceptual world. How about this one? I like this. This is a single helix. Every one of our cars has one of those. Spring, it's one of the more useful mechanisms. The mathematical formula for it existed long before we had the physical spring. Springs actually exist in nature, in the living cell. And we know what a double helix looks like, right? We hear about it all the time. DNA, double helix. This is a conceptual model developed long before DNA was discovered. Once we discovered DNA, then we could use this model to now graphically represent. But again, the shape itself is quite beautiful. And then nature itself, again, quite beautiful. We'll talk about DNA more. So now I want to blow your mind just a little bit, because I actually was a little surprised by this myself. This is a classic model of the solar system, flat disk. Here's Earth, there's the sun. But what do we know about the sun and Earth? Well, we're spinning at about 1,000 miles an hour. Kind of, 1,000 miles an hour. We are traveling around the sun at roughly 100,000 miles an hour. So we're spinning at 1,000, we're moving at 100,000, but we're in a galaxy that's spinning What direction is the sun moving? The sun is actually moving about 500,000 miles an hour along, I think it's the Sagittarius arm of Milky Way. So if the sun is moving at 500,000 miles an hour, what does it look like if you model it? Assuming the sun is not stationary. Well, thankfully for AI, I was able to actually do it. And this is what the model, the solar system looks like if you move the sun. That's kind of cool, huh? You know what that looks like to me, being an engineer? Concentric springs. If you know much about mechanics, we use spring inside spring a lot. That's a mathematical formula. That's our solar system. So I wanted to show you a more professional model of this. So remember that, again, the sun is moving 500,000 miles an hour. We believe the galaxy itself is running about 1.3 million miles an hour in the group of, because there's a group of galaxies that rotate. We've seen that in the telescopes. God's design is amazing. No matter what we do, there's always another level of complexity we haven't discovered. But let me show you this. When I saw this modeled professionally, I was just like, oh, wow. That's our solar system flying through the galaxy. If you think about it, it makes perfect sense. Gravity, the sun is moving, gravity is actually pulling us along. And it's a perfect spring or helix is what it is.
Is that in an orbit?
We're orbiting because we're being pulled along, right? The orbit is actually natural.
Is it slowing down?
We don't really have enough observable well, let me caveat. The outer arms of the galaxy are spinning faster than the inside is. I think that's right. Maybe I did it backwards.
Yes, they go follow.
Yeah. So the argument actually is if you round it out billions of years, spiral galaxies can't exist. It's actually one of the arguments we'll talk about in a couple weeks when we talk about astro. They can't because they would just be disks because they're not equally spinning. So if they aren't equally spinning for billions of years, then they won't look like that. That's one of the. I asked AI this afternoon to give me a list of the top 10 things that astronomy can explain based on the space telescopes. It's a very interesting list. That actually is one of them. So okay, I'll try to be quick. Math, fractals, logic and reason, and beauty. We believe as Christians, ultimate explanation for everything is obviously God. We can answer the why questions. The atheist has to revert to brute facts and necessity because they don't miss that necessary ground we talked about in the beginning. There's always something they can't account for. They always assume with more time they'll be able to account for it. But one thing I know as a scientist, the more we've learned, the further we've got away from understanding. There's more things we know. Mathematical intelligibility, our ability to understand math in itself. The Christian worldview says we understand math because we have a mind and it's made in the same way that God's own mind works. Comes from the mind, it's processed by mind. It's a logos. It fits well with what we see, what we observe. The atheist is stuck with saying, this is just the way it is. No surprise here, it's just the way it is, which is actually a more simpler explanation. There is an explanation or there isn't one. And that would be my challenge for the atheist. They don't have an explanation. Another one would be parsimony. We talked about it before. I think parsimony actually points to God as the simplest explanation for what we see because in the atheist worldview, they claim a method. And they don't want God of the gaps. I went backwards, sorry. They don't want God of the gaps, so they have gaps in their theories. They don't have anything put in the gap, so they say, well, eventually we'll figure it out. That's not putting something in the gap. That's being kind. It's called ignorance, willful ignorance, when you choose not to accept what you see, right? And then personal existential fits, right? What looks best? Well, in the Christian worldview, we know we have meaning and purpose because God put us here with a meaning and purpose. In the atheist worldview, they claim a method that is rigorous, right? But it lacks explanatory power. They always have a place where they can't explain. That's not very rigorous to me. Rigor means you can have an answer. Now, you can not like my answer, but to not have one is not, if we put it on the teeter-totter of the cumulative case, nothing weighs nothing. God is an explanation. Nothing we've done today actually proves God, but it definitely doesn't point away from God. And so it comes down to this idea of why does the conceptual and the physical look the same? Why are they the same? Why do we see these common patterns and then we see beauty in those patterns? Everybody does, no matter what color is chosen. You see beauty in those patterns. Why is that? Well, the Christian worldview is very simple. We say it came from the mind of God. God appreciates beauty. He said it was good, and we can appreciate those things. The naturalist worldview has to choose one of three paths, and they generally choose them in order. First thing they'll say is, you guys just have a false concept of pattern and beauty. It doesn't really exist. I think it exists. If it doesn't exist for you, I'm sorry for you. You miss out on a lot. Then they'll go to brute facts or necessity and say, well, you see it that way because it's just the way it is. It's the only universe we have to observe, so of course it's this way. That's a whole lot of words that said nothing. It's like, that's not an explanation. That is just dancing around the subject. And then they'll always go to, everything you see is completely explained by science. And I'm like, no and no. Because science, most of our modern science is not science, it's philosophy. Because science has to be observable, measurable, and testable. You can't do that for the origins of the universe. You can't do that for the origin of life. We can't even do that for evolution at the smallest scale. Now, they're trying to redefine it. We'll talk about that in a couple of weeks when we talk about life. But science doesn't explain everything. Amen.
That's literally where the word science comes from.
No, that's perfect because it's how we observe the world around us and try to make sense of it. That's what science really is trying to do. It shouldn't explain anything really. It sure can't make conclusions. Now, scientists make a lot of conclusions. I've written a lot of papers. I've made a lot of conclusions. But that's my metaphysical, observing the physical and then making a metaphysical claim. Scientists, atheists have to accept the fact that they are working in the metaphysical realm. If they do that, then all of a sudden, guess what is an open opportunity? You can't say anything but God because you're dealing in the supernatural world. Once you're outside of nature, then God is a pretty good explanation. So what do you think of mathematics? Now, isn't mathematics pretty? I mean, come on, you got to admit, those are kind of pretty.
My mind still gets lost.
But if you want to see more of the Mandelbrot, go look it up. YouTube, Answers with Genesis Canada. His name's Dr. Lyle. You can put in Mandelbrot set defeats atheist or anything like that. We'll bring it up. So it's very cool. So
I'm stuck on Mandelbrot. Okay.
Mandelbrot's a big name. Dan, would you pray us out?
Lord God, we just thank you for this beautiful world that you've given us. It's unimaginable. I'm so fascinated by fractals and just perfection that you have in your creation. We've done such a great job at destroying much of it. I thank you mostly for our Lord Jesus, who gives us life. Help us to continue to reach out to seek you. Ask all these things in your Son's name. Amen.
Amen.